First question. What do you got for an equation? Jackson? What do you got? C equals what?
-7.
-7 years old.
Yeah.
Yes.
N minus 7.
Yes, you take Noah's age minus 7.
That was close.
Okay. If you just have C equals -7, you're saying the cousin is -7, which means 7 years before they were born, which doesn't make sense. Input's going to be on this side. The input would be the N, which represents the cousin. No, N represents Noah. The output, the one that depends on Noah's age, is the age of the cousin. How about the opposite of that?
C plus 7.
There you go. And now the input is the cousin's age, and the output is Noah's age. If Noah is 15 years old, how old is his cousin? In months. Okay, well, to get the cousin's age, remember it's Noah minus 7, so 15 minus 7. The cousin is 8 years old. However, that's not months. Times 12 is 96. Mary, you are correct. Well, Noah's cousin is 132 months old. How old is Noah in years? So first, let's figure out months into years. 132 months is 11. So the cousin is 11 years. Remember, Noah is cousin plus 7. So 11 plus 7. Noah is 18 years old. Write a function that gives us the answer in months. Go ahead.
N equals M over 12 plus 7.
Yeah, it's got to be M because that's what it told us to use for Noah's cousin in months. Equals what?
But, yeah, but I thought it was M over 12, or M divided by 12. That's...
You take it times because you're finding out.
Yeah, so
Did I just get the variables mixed up?
it tells us to use M for Noah's cousin in months, so that's got to be by itself.
And then when
So it's N minus 7, and then whatever you get times 12. That's what we did for the first one, right? We subtracted 7, then took it times 12.
Well, didn't you say, like, when it says as a function of Noah's ages in years, doesn't that mean that that's...
Write a function that gives the age of Noah's cousin in months, so that has to go right there. As a function of, so that needs to go on the other side.
Sorry, I just got
Okay, the other one's going to be Noah equals. Now what did we do first? We divided it by 12 first, so we took the months divided by 12. And then whatever we got, we added 7 to. Input would be our M variable, and that would be the cousin's age in months. Output would be Noah's age in years. Question number 3. We did A and D together. We got B. Strang, what do you got for B?
X equals Y plus 2.
Very good. We're going to do a lot of those together today in today's lesson. How about the last one? Jordan, you got C?
Yeah, I got 5x equals Y.
Okay. That's not correct. Shouldn't be adding. You're doing the opposite of multiplying there. Yes?
X equals 5 divided by Y.
Should be Y divided by 5. Switch X and Y around. The opposite of times 5 is dividing by 5. Question number 4, writing the equations. Caleb, you got an equation?
Yeah. Y equals 12 times N.
Okay, let's see here. Number of years. So to get the number of months, you have to take 12 times the years. Because if you are 6 years old, you'd have to take it times 12. So 12 needs to go with the y.
Switch the variables.
So the other one, switch the variables around and divide by 12. Months divided by 12 gives you the years. Somebody says this baby is 36 months old. 36 divided by 12 would give you the years. Okay, why are the inverses? Well, you can tell because the input and output are reversed, switch spots. Question number 5, sketching these graphs. Yours might be a little different, which is fine. Height of your feet above ground while swinging. When I start on the swing, my feet are not touching the ground. If you're on a little short swing, I suppose that's not the case. But when I sit on a swing, and then my feet go up, down, up, and continue. If you're on a short swing and your feet are banging against the ground, I suppose you could touch the bottom. Height of your shoes above ground when you go up a ladder.
And then go down a slope.
And then go down a slide. So up a ladder, probably starting on the ground then, huh? It'll take a little time to walk up the steps. I don't think it'll be a straight line unless you're running up there, I suppose. So it kind of looks like a stair step, and then whenever you go down the slide, obviously, go down quicker than you went up. Distance from the center of the merry-go-round as you ride. And most of the time you sit or stand on the edge. And if you're not moving around, I guess you're going to be the same distance from the center the whole time. Your distance from your friend who's standing next to the merry-go-round. I'll start off pretty close to the friend, get further away, and then come back around, get pretty close to the friend, and then further away. It can be similar to the first one. Again, you'd cross the bottom line if you're smashing into your friend as you're going around the merry-go-round. Question number 6, which one is impossible? A. Can't have a negative hours. And it's a function of hours, can't have negative time. Describe the instructions in words so they can be followed by someone using a pressure cooker. X represents the weight of the steak. Okay, so your direction should say if the steak is between 8 and 12 ounces, it will take 7 minutes to cook. These are minutes. If your steak is more than 12 but less than or equal to 13, so from 12 to 13, it would be 8 minutes, 9 minutes, and so on. So starting at 7 minutes, weight, we're going to 8, up to 7, filled in circle. Going all the way to 12, 12 is also filled in. Going up to 8, now we need an open circle. It is not equal to it. And going over to 13. Open circle at 13, going over to 14. Open circle at 14, going over to 15. Open circle at 15, going over to 16. If it doesn't have the equal sign, the circles are open. Right side has the equal sign, circles are closed. Here's your input, these are your X's. And these are your output in minutes, your height. What kind of graph is that called? Piecewise. Piecewise function. Graph is in pieces. All right, determine if each point, will it work or not work? Distance from 0. For each point that you believe is not on the graph, change the output. All right, so if I guess -3, how far away is that from 0?
3.
Yeah, so that one looks fine. If I guess 0, how far is that away from 0?
0.
That one looks fine as well. If I guess -5, how far is that away from 0? 5. So that one's wrong. It does say to fix it. And -5 is 5 away from 0. If I guess negative 72, how far is that away from 0? That's fine. If I guess 4/5, how far is that away from 0? Alright, so that one is wrong as well. And it says to fix it. And it can't have a negative distance, can't have a negative y value.